Hello friends, I hope you have watched the video where I have grouped the Rodriguez formula. Okay, in that formula, in that proof, I have used a very important result that Pn of 1 is equal to 1. Okay, and in that video I have considered that this result is known to you. Then in that video I have also mentioned that I will prove this result in another video. So in this video today I'm going to prove this. Okay, so it is a topic of Legendre's polynomial, which is very important topic of special function, and very important. Special function is very important part of the part of the syllabus of mathematical physics for CSIR NET examination. So please stay with me, and before I start the video, please do subscribe the channel if you are new to my channel, and hit the thumbs up button. Also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you get the hype option to hype the video, then please do hype the video so that it gets maximum reach. Okay, so now let's start. And one more thing, if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. okay, now it can be proved easily using the Rodriguez formula, but as we use this result to prove the Rodriguez formula, that's why I'm not going to use the Rodriguez formula to use this to prove this result. Okay, so I'm going to expand the generating function to prove this. So let me show that. Okay, so now we know that Pn of x is the coefficient of z to the power n, in the expansion of the generating function, that is 1 minus 2xz plus z square whole to the power minus half. Okay, therefore we can write summation n is equal to 0 to infinity z to the power n Pn of x is equal to this. Right, so here this Pn of x is coefficient of z to the power n. Okay, so therefore we can write this way. On the left hand side, if you expand this summation, then you can write this way. Okay, 1 plus z p1 of x z square p2 of x plus dot dot dot, so on, z to the power n Pn of x plus dot dot dot. So here I have put n is equal to 0 to infinity to get the summation of this series. And on the left hand side, what we can do, let me keep it this way for the time being. Okay, without any change, that's what we get. Now you see, we need to find that Pn of 1, right? So in order to find that, let me put that x is equal to 1 on both sides of this above equation. So on putting x is equal to 1, that above equation will be of this form. Let me write that form. So P1 of, instead of x, let me write 1 here, because we are putting I'm putting here 1, x equal to 1. So similarly z square p2 z p2 of 1, sorry, not z, dot dot dot, z to the power n, we're gonna have Pn here, and x is equal to 1. So Pn of 1 plus dot 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 up to infinity, and right hand side, on putting x is equal to 1, we have got 1 minus 2z plus z square whole to the power minus half. Now you see, this part which is within this bracket, this is in this form, 1 square minus 2 into 1 into z plus z square, so which means it is 1 minus z whole square if you apply the a minus b whole square formula, right? So we're gonna get this 1 minus z whole square whole to the power minus half. Okay, then here this square cancels with this, right? Hope you have understood this. Then we're gonna have 1 minus z whole to the power minus 1, right? And if we use binomial expansion to expand this, then we're gonna have 1 plus z square plus z cube plus dot 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 z to the power n plus dot 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 up to infinity, right? So here you see the coefficients of z square, z cube, dot dot dot, z, and in each and every term coefficient is 1 here. So if we compare the coefficient of z to the power n on both sides, comparing the coefficients, coefficient of z to the power n on both sides, what we're gonna have here, you see, here we have z to the power n, its coefficient is pn of 1, and here the z to the power n, before this we don't have any number, that means there is 1, so 1 is the coefficient here. So that's why comparing the coefficient of z to the power n, we must get pn of 1 is equal to 1. That's how we can prove, right? So hope you have understood this.